Keith, maybe give us a sense that the segments can all move independently. Is that correct?
That's right. They can tilt. They can move in a lot of different directions. And again, it's not a lot of movement, but they all can move in different directions to align themselves. They can also be pushed and pulled a little bit to sort of change their radius of curvature a tiny bit. So all those different movements have to be well coordinated, and it's quite the challenge that the optics team has coming up for them to do that. So that's really groundbreaking. Really groundbreaking what they're getting ready to go into, which is aligning those 18 segments. So they have full control over all of them. But even though they have full control over them, they have to get the data back down to the ground or where they are. And again, a lot of ground system processing to compute the next move, and then they'll just keep cycling through. And at the same time, they're imaging. They're taking reference stars to make and using those reference stars to help them align and focus the telescope. It's a very painstaking process. It's groundbreaking, but it's going to be really something when they get it all done.
And one of the other parts of the commissioning that I think is just incredible is that because this telescope is operating at just low temperatures, a lot of people are familiar with the idea that materials expand and contract and change shape as they change temperature. And so these mirror segments, which are made from beryllium, it's a type of metal that behaves very well under very cold circumstances. It keeps its shape; it works very well. The beryllium segments actually were ground to a curvature that isn't correct when it's at room temperature. They actually need to cool down to this operating temperature that we said, which is close to minus 400 degrees Fahrenheit. And it's only at that operating temperature that the curvature of the mirrors are correct. Is that right, Keith?
Yeah. And again, that you're going back, again, the development history is just doing that very operation and making those mirrors. So we'll stand by.
I see something happening in the mock. People are getting excited.
Okay. Here we go.
I can confirm the final lap signature on the aft MTS, which indicates that all 5 layers of the Sunshield are fully tensioned.
How exciting.
Significant milestone accomplished. Job well done, Sunshield team. Job well done.
Yeah, so...
Thank you, Mom.
All stations, this is Mom on Ops. All stations, this is Mom on Ops. Stand by for PM.
Hey, guys, I just want to congratulate... This is Jeff Ops. You can go ahead and execute GE stop deploy.
Copy. Executing.
This is incredible to see. We're watching live footage of the mock, the Mission Operations Center. It looks like we are very close to declaring victory on the deployment of the Sunshield.
Yeah,
I can confirm motor stop. We'll stand by here.
Congratulate our team downstairs.
Whatever they want to
do. Many years in the making, right here. So not just for NASA, all of our industry partners. It's just an amazing achievement. So I just want to congratulate our Sunshield team right now. What an achievement.
Okay. Hey, I just want to take a moment to congratulate everybody. This is a really big moment. We've got a bunch of work to still do, but the Sunshield has been unbelievable after many years. Sorry about that. Since I don't normally talk, we bring the mic down. Anyway, so I said this is a really big moment. I just want to congratulate the entire team. We still got a lot of work to do, but getting the Sunshield out and deployed is really big. You constantly reinforce what I tell everybody, that the JWST team is the best in NASA. There's hands down nobody better than what we have here. You guys should all take pride in all these accomplishments. One of the things I've told folks, and I've even put in emails, this is so unique what we do in this mission. We are going to be bonded forever by what we experienced, not only just through operations and with the mission ops team, but over the last, all those who've worked on it over 20 plus years. And finally, I'll just tell you what I put on Facebook last night when I shared the story I just said the JWST team kicks butt. I didn't use the word butt. I used another word, but I won't use that word here. Congratulations, everybody. Hooah! Hooah!
Absolutely awesome. So yeah, this is we'll let our celebrations continue. This is incredible. What an incredible week. But folks like me are looking ahead right now. I'm looking ahead deployment and can't wait to get that out. So but congratulations to our entire team. Just awesome. And just want to pass along some thanks to everybody viewing this, everybody who's been rooting us on.
And all stations, this is my line ops. We're going to hold right here for just a moment. All stations, this is my line ops. Just hold right here for a second. Enjoy your moment, and we'll pick up with that.
Just as you said, it's so wonderful to have all the people that are joining us around the world for this event. This is truly incredible. When I first saw the design of the James Webb Space Telescope and just the ambition of it and the size of it and the scale of it and this giant heat shield that needed to come out and so many things needed to work, it took my breath away. And I'm here. I'm actively getting goosebumps. I mean, this is a wonderful, wonderful time. How are you feeling, Keith?
Oh, yeah, it's just, like I said, half my mind is going, woohoo, and then the half of my mind's going, let's get that, we got to get that secondary air out. So that's just how my mind thinks. So, but that's good. That's good. But, no, this is really good. I mean, and Webb is absolutely, hopefully everybody is becoming iconic a little bit. It is absolutely a beautiful spacecraft. We did not design it to be beautiful. We designed it to be functional. But as a fact of making it functional, it's absolutely a stunning spacecraft. I did get to spend a few minutes with it in the clean room before we shipped it down to launch, and I was just amazed at just how beautiful of a machine it is. So, and that machine is really a function of hand built by this team. So a salute to them.
Absolutely wonderful. So to confirm, Keith, we have final confirmation that the heat shield is entirely extended and tensioned.
All stations, this is Mom on Ops. We're gonna jump back into the cast chair and continue with the coolest thing in space. There is nothing cooler in space than JWST. That's a fact. So, OC, this is Mom on Ops.
OC on Ops.
I love that. The coolest thing in space. It will be soon.
As you can tell, even though we finished this up, we're going to move on to this evening's activities right off the bat. So we have some more 24-hour operation there, and we're constantly doing new things.
At 626.021, Jeff Lead has confirmed that the membrane tensioning is complete. So at this time, we're ready to continue with 626.022, DEU to standby.
Copy that.
So what's going on?
Rock looks good.
What's going on now is our we're going to start shutting down or reconfiguring our electronics and turning off our motors, and basically tell our electronics that have been driving these deployments that their job is done. Thank you very much. You did your job, and now you get to move on to your next thing. So that's what they're doing right now. They're just basically shutting things down and getting configured for the next operation. So you may hear some of that.
Well, just many congratulations, Keith. This is just incredible.
Yep.
So you hear about the preparations. Sorry.
No,
I didn't mean to step on you there. You've heard about the preparations.
Oh, I'm sorry. I keep stepping on. I just want to thank you guys for putting these productions together, because it's just awesome to bring
standby mode around
this out there.
We're ready to continue with 626.023. And that clock looks good. You'll go to continue or go to execute.
Executing.
Okay.
So as Keith just said, they're getting ready to